Hello, everybody. Here we are in the workshop by Mey about Tablecloth. Tablecloth, this table processing, data processing library that some of us like very much. And this is part of our workshop series that we're having in November. And thank you so much for Mey for preparing this, and for Tomasz Sulej, who wrote Tablecloth, and Chris Nürnberger, who wrote TKML dataset, which is behind the scenes of Tablecloth, and is the magic happening behind the scenes. And it will be a fun workshop. Yeah, and please follow all the workshops we're having this month. We'll have many interesting topics. And yeah, let us begin.
Okay, woo! So I'll start by sharing my screen and share. That's it, started. Please, everyone, pray that it will all work as planned. And if not, we'll see what happens. Isn't it fun? Okay, so hi, everyone. I would like to start with thanking you, each and every single person that decided to take your time and join us. I think I appreciate it. I'm sure that I appreciate it even more than going to a physical meetup, because I'm sure everyone has all these Zoom meetings all day, and choosing willingly to join yet another Zoom, that is brave, and I appreciate it. And I promise that we'll have fun, or I'll try to do my best so everyone will enjoy this workshop. And yeah, I'm excited. Can you tell? I guess. Okay. But I'm always excited before I start a workshop or a talk, because, you know, I want to share my knowledge. I want to share things that I created. And I always hope that it will work out for the best, and that everyone will understand and take something away from this workshop or a talk that I do. So, yep. Pokedex workshop. Gotta join them all. That's a joke. Okay. Yes. So let's start. Hi, my name is Mey. I am a software engineer. I'm a backend developer at AppsFlyer, and actually tomorrow I'm starting a new job. So this is kind of a not really updated for tomorrow. So it's updated for today, not for tomorrow. Tomorrow I'm going to start at a wonderful company called Forter. So, woo, wish me luck. Also, I'm a sworn Star Wars fan, and if this was a physical meetup, I would be wearing these. So you're all obligated to see my R2-D2 heels. Can you tell? There you go. Yes, it's real R2-D2, but it's not a physical workshop. So I always have them here, so everyone will know that I own these. You know. So yeah, I think we're ready to start. Data wrangling in Clojure. Yes, so I've had some time in my hands, and I was looking for something fun to do. My definition of fun is doing things with Clojure. I hope some of you will agree with me if you joined us today. That's because I actually enjoy writing things in Clojure. I always feel like I don't know how it will end up being, and I don't know how I'm going to do that, and it's a great challenge. So that's why I looked for something to do in Clojure, and then I started talking with wonderful Danielle here that helped me every single step of the way. And when I started thinking about what can I do in Clojure, I had a few questions in my mind that troubled me, but the question that troubled me the most was, which Pokemon would I be if I was a Pokemon? And I felt obligated to answer this question, and I felt like there are other people in this world who feel the same as I do, that they need to know precisely which Pokemon they are. Okay, so that's a part of what we will do today. I hope you don't take me too seriously, because you know, it's a Pokemon, but that's part of the fun, I guess. Which brings me to the next thing. That's the dataset that we're going to use. We're going to use two Pokemon datasets. The first one is all Pokemon data sets from all generations, and then the other one is the Pokemon battles. So I'll step right out of the presentation for a second, and I'll show you. They're both taken from Kaggle, and you can see over here the Pokemon CSV. We have like 41 columns. I'm not going to use all of them. I actually, yeah, let's do that. So what if I hand choose while you're all waiting? You've got time, right? You're already here. So, but I promise it's going to be worth it. So name, let's just take a look. Name and Pokedex number, and let's do weight. I think that's enough for now. Let's also take height. Okay. So there you go. The link to this data set, like I said before, is in this chat and also in the Zulip chat. So these are the main columns that we're going to work with. What you see over here is we have 801 Pokemons, and we have their names in English. There is also a column for Japanese names, but I chose the English one for obvious reasons. And we also have their height and weight, which is how we will use these values to determine which Pokemon we are, which makes it so accurate. I wanted to add more fun things to it, but I also had to keep it kind of simple. So I encourage you to, try and find out which Pokemon suits you the best by using more of these columns over there. Yeah, the last column that I'm going to talk about is the Pokedex number. The Pokedex number is actually a unique number for each Pokemon, and that's going to help us when we use the other data set. And let's take a look why. So the other data set that we have is Pokemon battles. It's so cute. You have just 3 columns over here. It describes combat between 2 Pokemons. And as you can imagine, the numbers over here, they represent the Pokedex number. And since the Pokedex number is a unique number for each Pokemon, it's easy for us to play around with this data set, and I found it wonderful. We have the first Pokemon who participated, the second one, and then we also have the winner. So we're gonna have some fun with it. Yeah, so I chose these 2 data sets. It was really fun, and it's something that I want to stop and say right now. If you choose to start doing things with data, and you want to start, I don't know, not just having fun. Obviously, we want to learn things and maybe to be able to use it later on for work or for future more serious projects. And I say serious like this because for me, this is also serious. I just I do it for the smile, so maybe it doesn't look so serious, right? So when you choose a simple data set, and when I say simple, I mean that you fully understand what's going on here. It doesn't describe something complicated. It describes Pokemons, So there are 2 things about it. First of all, you understand what you see because it's only 3 columns. And then also over there, even though that there are 41 columns, it's very easy to to think about what values you expect to see from different things, right? About the height, about the weight. And the second thing is that you can do different queries and play around with the data, and you can again think about what the answer of your query is going to be, and it's easy to check if you were right. So again, that's why I recommend, if you're just a beginner in this whole data world, start with something simple that will be easy for you to check yourself, to test yourself, whether you're doing it right. But that's just my 2 cents of how you should start with things. Let's move on. So obviously, we're here to talk about not just Pokemon's. Yeah, we are actually here to talk just about Pokemons, but how are we going to do that? We're going to do that using the wonderful, wonderful Tablecloth. And over here, I gave you the 2 links for both the documentation and the GitHub of Tablecloth. And during the workshop, I'm going to send you to this documentation to search for things yourself. Actually, not during the workshop, like at the at the second part, which I'm going to talk about right now. So this workshop is going to be divided to two parts. The first part, I am going to show you different things that I do with this data set, with those two tables that we have. I'm going to show you the code and how to do it. And then at the second, and then we'll take maybe like a short break. And then at the second part, I prepared a few questions for you guys, a few queries for you guys to try and do it yourself. And I'll post the answers later on today, because I kind of want you to try it, you know, and succeed in doing that. And I'll post the answers later on today to my GitHub account, and I'll share the link in my Twitter and in the Zulip chat and everywhere, maybe in Instagram, I don't know, I'll put it everywhere so you won't miss it in case you really want the answers. Okay, so let's begin. The first part. Whew, I'm gonna take a sip of water because I feel like I'm too much. Okay, not too much, a little bit too much. Okay, I'm still too much, but what can you do? Okay, so what we're going to do is we're going to use SQL queries. Now, I don't know how familiar everyone is with SQL, and it matters partly. Like, I assume that you're kind of familiar with SQL, which is more than enough for what we need today. And now I'm going to tell you the reason that I am using that. So in Tablecloth, a lot of the functions that you have over there reminded me of functions that you can find in SQL. And since I am familiar with SQL, and I worked with it, it was easy for me to think about queries and then try to translate it into Clojure using Tablecloth. And the other thing that I did was I started by writing these queries, and I checked the results of these queries using SQL in a dedicated online website. You know, I just put there, I uploaded the two CSV files. I wrote, you know, valid SQL queries. I got results. And then when I wrote it in Clojure using Tablecloth, what I did was, here, you can see that over here. I could see, oh yeah, it's kind of, okay, so it's not, it's, okay. I had to reload it, but just believe me that you can use this website. And I also shared the link to this website because I found it easy to just upload the CSVs over here. Just like you can see that there is a demo. Like what I would do is I would upload the CSV files over here, and I'll start writing some different queries, and I'll check what I got. And then you can check it out if the queries that you did in using Tablecloth, if you got the right results. So that's just, you know, you don't have to do that if you're not familiar with SQL. It gives you a headache. Some people hate SQL. So it's just a suggestion. That's it. So that's what we're going to do. The first thing that I will do is I will show you how to present different columns from the CSV, filtering only the columns that we want. The next thing that we will do is after we filter the columns that we want, we will order by height, meaning we can understand which Pokemon is the tallest, you know, Pokemon. Then what we will do here is test your query here. Again, I'm sure you can find your own other website. Somebody unmuted himself, or okay. I think someone unmuted himself, so maybe they should close the mute themselves. So what we have over here, like I said, I wrote test your query here. I'm sure that there are other good websites, but this one was easy enough for me to upload the CSV and test it online. And this huge, not that huge, I've seen worse. This respected SQL query, what it does is we're going to use the two data sets, the Pokemon and the Combat one, the Combat CSV, and we're gonna get Pokemons that are between height range and weight range. And then we're also going to find out how many times they won. And that's the final query that we're going to do. So again, even if you don't really understand SQL, that's totally okay, because I'm going to explain each part and every step that I'm going to take. So it's just meant to help you. And if it distracts you, just don't listen to me when I talk about the SQL part. Okay, these are the things that you're going to try and do yourself later on. And that's what I said, that I'm going to post the answers. I think that these are great questions. I'm sure everyone wondered which Pokemon is the heaviest Pokemon. That's such an important question, in my opinion. Okay, so let's go to some coding. I am dancing and singing. I hope nobody will run away from me because I did not warn you before I started singing. Maybe I should do that, you know, maybe next time before I start singing, I'll be like, hey everyone, I'm gonna start singing again. You can shut your ears. Okay, so REPL, the REPL is running, yes, and let's do that. So what I have over here is in resources, I have the combat CSV, like I said, and the Pokemon CSV. Here you can see that I put both paths, and we have another path. I'll explain this one shortly. So over here, I have the entire code because I am sure that you all believe me that I can type. So I wasn't gonna let you stare at me typing. So every time what I'm going to do is to just cut and paste, and we're going to run, you know, some parts of the workshop. You know what? I'm just going to put it in another screen. If you guys can wait like 1 second, that will be so nice. Not like you have a lot of choice, right? Like, what would you say? No, we're not going to wait. So there you are, waiting while the other screen is, I turned it on, but I won't hold you for too long. Let's take the first thing. Wait, did you lose me? No. Okay. Okay. Some things are not supposed to be done while you're already at the workshop, but I just did. So, okay, but it worked. Okay. All right, so now I have it in a different screen, so I won't have to like jump back and forth too much. Let's begin. So the first thing that we want to do is to actually load the CSV. And no, that's not right. We want to load the CSV, and we want to take a look at the table. So let's do that. Let's start with the combats one, because it's, you know, it's the smaller one. It's a good place to start with. All right, now let's see. And combat, oh yeah, enter. All right, so now you can see, okay, you can see it, it's here, right? We have 3 columns. We have first Pokemon, second Pokemon, and winner. It's even printed very nicely, you know, as a table. And let's talk about how it's printed. What we see over here is on the left side, it says resources combat CSV. That's obviously what it prints to the REPL. And we have 50,000 lines, and we have 3 columns. And out of those, out of all of these lines, what we see by default is just the first 25. Okay, so let's move forward and see the Pokemon dataset. All right. Okay. Bam, we have it. Okay, so now we have all of the 46 columns, but wait a minute. Didn't it say at the Kaggle that we only have 41 columns? that's the first thing that I want you guys to notice. When you load your data, or when you start handling your data, before you even do anything, the first thing that you want to do is to make sure that your data was loaded correctly. That maybe there are no missing values or weird values, you know, with the characters that could destroy your query or something like that. So this is classic what we have over here. When I just begun using that data set, I didn't understand how come I was scrolling through, and when I went to defense, it said seed Pokemon, and then, you know, it started to have weird values. And also when I went to name, I saw that under name I got the Japanese name, and under the percentage male I got the actual name. So this is how I realized that my data is not loaded correctly. And, you know, here's another hint. Pokedex number is supposed to be a unique number for each Pokemon, and here we can see that we have the same number for more than one, right? So this is what I want you guys, again, that's something that is important for you guys to take on forward, right? You want to check whether your data was loaded correctly. So what happened, I'm gonna just tell you, because I kind of, you know, we don't have all the time in the world, but so I'm just gonna tell you that what happened was that I have those single quotes over here, which ruined it for everyone, you know. And what it did is that if I have, like, each one of the abilities got its own column. So over here I had two abilities, so it overgrow and chlorophyll. I got it in two different columns, and let's say over here I got three, so it's spread it across three columns, and you know, so on. So in order to fix that, there are a few ways, and it's something that I would love to discuss with you guys later, and actually get your thoughts about it. Because what I did is I just replaced the single quote, and I'm not sure it's the best solution, but it's a solution. And why it's not the best solution in my opinion, because changing your data, editing the data itself, I don't know, I find it debatable. And again, I'd love to hear your thoughts about it. And this is load the Pokemon CSV. So I'd love to hear your thoughts about, what do you think I should do if I have invalid data like this? But not now, let's keep it for the end, right? Let's just keep it in your mind. Let's talk about it later. So over here, you can see that what I did is I used slurp to load the file, replace, and then spit it into a clean Pokemon DS path, which is the new CSV that I'm going to create a new CSV. As you can see over here, we don't have that CSV yet. So I am creating a whole new CSV with replacing the one thing over here. Sometimes when I'm too excited, I start, you know, a little bit of that. But you forgive me, I hope. Okay, let's load it and see what's happening. Oh yeah, I wanted to do the Pokemon, not the S-Pass, but this one. Let's change it. Yes. And okay, now let's do it again. And now Pokemon DS. Much better. I mean, I know, because it worked, so perfect. It takes some time for it to actually show in the resources, but it's already created. Sometimes IntelliJ is slow, but I like working with IntelliJ, so it's okay. All right, we have that now it looks good. First of all, we can tell that we have 41 columns, and if we scroll all the way, we have the Japanese name and the name. Perfect. Let's move forward. So we loaded the CSV, we cleaned the data, and we present the table as it is. Next thing that we're going to do is select specific columns. Let's do that. So selecting specific columns is done like this. Let me just close this because we don't need it. So now I think it's better. Is it big enough? Okay. Is it better this way? Okay. I want you guys to be able to see well. Okay. So should I make the font bigger? Anyone? Or is it okay like this? If it's okay, just do this. If it's okay, just do this. It's okay? Okay, perfect. Thank you, Danielle. So select specific columns. What we're going to do is we're going to use the select columns function. And I kind of want to go to the documentation just for a minute, because I want you guys to see if you had to look for this. I mean, I'm sure you can do it, but I just want you guys to get familiar with the documentation. I think it's important. Is it still shared? Yeah, right? It's still shared. Daniel, give me a quick nod if it's still shared correctly. Can you see the documentation?
Yeah.
Okay, perfect. So over here, you can see columns and select. So there you go. You see that what I want you guys to see is the documentation is easy. It's easy to go around and find your way. So yeah, that's what I wanted to show you. So select columns. What we're going to do is select columns that we're going to pass over here. And we are using keywords as as a part of the input, and the order matters. Like if I put the Pokedex number first and then the name, that's how it's going to present later on. So this is yes. And now okay. All right, Pokedex number. You see we have the first 25. Perfect. Next thing what we're going to do is let's find the shortest Pokemon. Okay, let's find the shortest Pokemon. And we're going to do that by using the order by function. I'm sure you're all super excited. I'm singing about finding out which Pokemon is the shortest one. Woo. Okay. Sandslash. You know what I'm going to do now, right? I am going to Google this Pokemon because I promised you guys will learn new things. So Sandslash. Okay, this is the smallest Pokemon. Now you have this important information. And the other important information that you gain right now is that the order by function, the order by function actually orders from the smallest to the biggest, so it's ascending order. So if we want to find the tallest Pokemon, like if we want the order by to be descending, then all we need to do is to add the keyword descending over here, right? And again, just like in the select columns that we pass the vector with the keywords, that's also what we do with the order by function. We pass on what we want to order by as a part of the input. And then, like I said, if you want it descending and not ascending, then that's all you have to do. Just for the fun of it, let's see. And it's Wailord. You know what's coming, everyone. You know it's going. Let's see, Wailord. Okay, that makes sense. That's the biggest one. Okay, that's the biggest Pokemon. Makes sense. Good. I hope you guys are ready. We talked about how we load the Pokemon, not just the Pokemon, right? We talked about how we load a data set like from a CSV file. We have it over here. And then we also talked about cleaning the data over here. And then we saw the select columns. We talked about order by, and then now what we're going to do is we're going to start constructing the bigger query, like I promised before. So remember, even if you're not familiar with SQL or you don't like it or anything, that's okay. I'm only using it, to help those who find it convenient. But I'm going to explain every step of the way. So don't worry, okay? Okay, I'm answering myself. So, which Pokemon are you? I'm going to go line by line and explain what's going on here, and then we're going to do it with Clojure, with Tablecloth. And then after that, we're going to have a break. Perfect. Now that you know the plan, let's move forward. So select specific columns. We already know how to do that. We use the select columns function that like we have over here. From the CSV file, we talked about it. That's the Pokemon DS that we loaded back up there. Then we have left join, and I'll go back to that in a moment. And then we have where height and weight are in a specific range. So what I want is to give a predefined range of height and weight of a Pokemon, and I want to filter the values from the Pokemon's data set to have only values that are in the range, okay? So then the last part will be to create another query, which is like an inner query. And this query is going to be done on the combat CSV, or I called it battles over here, but it's actually combat. So just so it will be clear. So it's combat CSV. By the way, this is a valid SQL query. You can all later on copy this one and try it in the SQL Online website. I'm not that in love with SQL, by the way. Just maybe it looks like I'm like so in love with SQL. I find it okay. It was just super helpful. Okay, so the second part, like I said, we're going to count how many times each winner won. Like we're gonna have a winner column, and then we're gonna have count how many times each Pokemon won. And that is going to be done using the group by and the count function. And then we're going to join the two tables using the Pokedex number. Like I said, because we know that the Pokedex number is a unique value for each Pokemon, that's going to help us later. Okay, let's begin. Okay, so the first thing that we need, let's take this. This is, I called it user info. These are the values that we're defining in advance, right? So the user height and the user weight. And let's take these two functions. And now let's take these two functions. These are two simple functions written in Clojure. And what these two functions are doing is we get a row from the CSV as an input, and the row that is from the CSV will be given to us as a map, as a Clojure map, key value, right? So what we're going to do is we're going to be able to extract the weight from the row just using the keyword function, and that's it. So I don't know, for me, it's magic. I mean, it's Clojure. For me, Clojure is magic. I think it's super cute. So now if we want to get a Pokemon in a height range, let's do that. we have the select columns, which you're already familiar with this function. And now we have, hello, select rows. Why? Because when we wanted to filter columns, we use the select columns now. And now what we want to do is to filter rows by the values that are in them, right? So the way we do that is we pass into the select rows, like when we had the select columns, we passed on the columns that we wanted to get. And now what we're going to pass on is a function that we are going to filter by. That's how we're going to decide if we're going to filter the value or not. So let's see this in action. Oh no, I have an error. Okay, I'm kidding. I knew I'm gonna get this error, but I wanted you guys to see it. So this is a part of getting to know your data before you start doing things. Remember, I said it at the beginning of the workshop. Well, this is why I believe it's a good idea to check your data set at the beginning, before you even start doing anything. What does it mean check? You want to look for, like I said, you want to look for missing values, and you want to make sure that the data set is loaded correctly. And over here, what we got is null pointer exception. And that's because these functions, they won't check for null values, and it produces an error. And now again, added to I think this is something that will be fun to add to our discussion at the end. How would you handle it? Would you just check it like I did? Like, let me show you what I did. And, please tell me if you guys think it's a good idea. Maybe you guys think it's a very bad idea what I just did over here. I'd love to hear your thoughts. It's just things that I did for this workshop, but I don't know, I always want to hear other people's opinion. So what I did is I just checked for the if the value is there or not, right? For null over here. That's it. I did a quick AND function, and then I did the function that checks for the range. So this is how it is. And whether the value exists, and also if the value is in the range. And the reason that I'm not going deeper into explaining these functions is because if you're familiar with Clojure, then I'm sure you'll handle it. And if you're not familiar with Clojure, I have a whole different workshop of teaching you guys Clojure. So we're not going to do it today, but you're welcome to join the other workshop at some other time. Okay. So now that's what I did. I used these. Let's see if it works. Now that we have now what we have is Pokemons in a range that are in the height range of between 0.5, between 0 and 1.5. Yeah, that's what I had over here. So we only got the first 25 values. That's it. Now, let me just do, okay. But what I promised you, if we go back to the query over here, what I promised was both height and weight. So like in Clojure, what we can do is add the end function over here, and do an end function between the height and weight in range. So I'm going to show that now. Get Pokemon in height and weight range. Let's do that. This entire code is in GitHub, is in my GitHub. So you can all take it later and play with it. So don't worry about it. So there you go. You see over here in the select rows, I sent the name of the height function, of the check, height in range function. And what I do over here in line 105 is I just create a function right in here, fn, that gets a row as an input, and it's using the end function between the weight in range and height in range. And that's also something you can do. You can either do it like this, or you can do it like this. That's the select rows. Perfect. Okay. Hard stop. Right. Now let's run this, and then I'm going to do to say something. Okay. Hippopotas. That's the only one that is super short and 50 kilos. Do you guys want to see? I think you do. I think you do. Let's see, short and 50 kilos. Hi there, hippopotas. I'm gonna tell you, Daniel, I'm gonna tell them that it's your favorite one. You said it. I'm sure that it's information that is open to the public, right? Okay. So hippopotas. Okay. Yeah, let's do like another value, maybe like 10, see if it gives us something different. Right, so this gives us like a range of Pokemons, right? We have a few tiny Pokemons who don't weigh as much, and they are tiny. Perfect. It's not that tiny to be under 1.5 meters, right? Speaking of which, I'm 1.5 meters, so it's not. I'm saying tiny, but it's okay. I'm tiny. Being tiny is good. Woo! To all the tiny people, I'm not that tiny. I'm okay. Okay, now I'm going to move to the second part. So here, going back to our query, what we see over here is like I said, we filtered the column that we wanted. We took it from the Pokemon CSV file, you can see over here. And we got Pokemons between height and weight range. That's what we have right now in the REPL. Now what we need to do is we want to do the other query, which is going to be done only on the Combat's CSV file. So I'm going to take that just for, it doesn't matter that it's all the way up here, but I'm just for my convenience and for your convenience, I'm going to take it all the way down here so you can see what I'm doing. But, obviously it doesn't matter if it was all the way up there, right? So loading the Combat CSV file, let's make sure that we can see it. Combats CS. Perfect. Okay, so now let's start. What do we need to do? So let's close a few of these. I don't need all of them. So there you go. Okay, what we need to do is to select winner. We want to create to have two columns. We want to have the winner column and to count how many times each Pokemon won. And we want, so it means that, and we want to group by winner. This is how we can use the count function. What does it mean, group by? Okay, so I'm going to explain it to you right now. And for those of you who are already familiar with the group by function, please forgive me. I'm doing this for everyone. So group by, what we see over here is that we have a number, let me see. Okay, number Pokemon 701. This Pokemon, he won in this battle, right? In this battle over here against 702. And if we go all the way down, we can see that he also won in the battle against 624. So it means that 701 had at least 2 wins, right? And so grouping by winner means that we're going to put the lines, the rows that have the same winner in the same group. And this is why it's called group by, because we're grouping it by the value of that is in the winner column. And this creates a group. And then later on, if we want to do to take actions on each group, we can do that. after we used group by. So we start with using group by, and then we activate another function on it. It means that the function will be activated on each group separately. So let's see that in action. I hope it makes sense. I'm going to start by showing you just the group by winner. Okay, group by winner. So again, we see that it's repetitive if we write the name of the function over here, and then we send which column we want to actually group by. And now let's see that in action. Okay, so now I'm going to explain a little bit about what is being printed over here. So over here, you can, again, we can tell the number of lines, the number of rows that we have is 783. We have 3 columns, and what you see is actually not the groups. It's a representation, it's the default representation that was done in here. So the group ID is, it's just a counter for each group. Then under name, the name is given by the value that we took. Remember the Pokemon 701, we saw that he had at least 2 wins. So over here, the group itself, it says again the name of the, this is the key, and the value is the group. So we have 101 rows and we have 3 columns. And again, the reason that it's been written like that is because we have each group, each Pokemon that won, we have all of the rows together for the Pokemon who won, like 701. I hope it makes sense. We can discuss it more later if you want. So I'm going to move forward now to doing the counting. So now I want, I want to count. So what does it mean to count each group? It means that I expect to get these values, like 105 for Pokemon number 701, because I want the number of rows that for this Pokemon, which means the number of times he won. Okay, let's do this. And ta-da. Now what you can see over here is that, again, I'm going with the 701 Pokemon as our example. We saw that it said over here that there are 105 rows. And yes, when we count the group size of 701, it's exactly 105. So we used Combats DS. This is the CSV that we loaded. And now that's the Combats dataset. Then we use the group by winner, that's over here. And then we use the aggregate. And since we're using the thread macro over here, then what happens is these functions will be executed one after the other. So after we grouped our data set, we're going to activate the aggregate function, and it's going to work on each group separately. And that's going to activate the row count, and we are going to call the new column number of wins, which you can see over here. That's my name, right? That's the name that I gave the new column. Okay. And I also wrote it over here. Adds another column to the table. Each row holds the size of the group it belongs to, which is what's happening over here. We're getting closer to being done. Okay, next part that we're going to do is the join. Okay, but before we join, so what does it mean to join? I want this table of the winner and number of wins. I want this to actually be concatenated with the Pokemon's data set that we had before. And I want that each winner number over here, which is a Pokedex number, I want it to match with the Pokedex number from the Pokemon data set. So what I just described is called left join. And now I am going to bring, before we do the left join, I want you guys to know that when you do a join, which means concatenating two tables, in Tablecloth, it's being done using, like if you have the same column name in both tables. So over here, we have the winner column, and I want to join it, like I want to match it with the Pokedex number column. So what I'm going to do right now is I'm going to rename, I'm going to use the rename function over here. I'm going to rename the winner column, and I'm going to name it Pokedex number. So that's why I wrote over here, join will be done by matching columns by their names. So rename winner to Pokedex number. And this is how it's done, using the rename columns. Okay, let's do that. See if I actually renamed it correctly. Nah. Oh yeah, because I need to do this. Yes, he's right. Number of wins. It works. Perfect. It's because I used the def. So yeah, that's why I had to call it number of wins. Okay, perfect. Number of wins, Pokedex number. Now we can do the last part, and we can do the entire, not the entire query. No, that's not what I plan to do again. And paste. Woohoo! You guys, are you excited? We have like 1 minute before the end, and we're almost done. I'm excited. Okay, I know my energy is endless. That's it. That's what's happening. I'm gonna take a sip of water before I just sip of water. Okay, I hope you're ready. I called it Pokemon filtered because what you see over here in those few lines, because isn't it magic, like Clojure? Look how tiny and beautiful this is. So what you see over here is this entire thingy. I'll go line by line just to, just to remind you guys what you see. Although, I hope that by now you're good with what with what I presented. So we have the Pokemon dataset. We're using the thread macro on the Pokemon dataset, which we loaded earlier. We have the select columns function, and we sent it the columns that we wanted to get. And then we used the select rows, which filters each row by the value that is in that row. And we sent it a function that we prepared over here using fn and weight in range and height in range. So we wanted to get Pokemons that are in these range that I provided before. And after we're doing all that, we're doing a left join with number of wins, which is this thing in lines number 123. And we're using the Pokedex number column because, like I said, the joins are done with columns that have the same name. So let's see that. And Pokemon filtered, that's what I need to do. Pokemon filtered. Are you ready? Yay! We have 24 lines and 6 columns, and you can see now that Frogadier is tiny, but it has like a weight of 10 kilos, and you can see the number of times that he won. He won 64 times. That's so good, little froggy. Very good. one strong frog, right? Yay. Okay. I don't see other Pokemons that I like over here. I'll go look for them later. I'll go look for my favorite Pokemons later. But actually, this is it, you guys. This is it for this part. We're not completely done. This is it for this part. Let me go back to the let me go back. Oh, yay, hippopotas. Let's go back to our presentation, and let me just say a few things before we move forward. But I'm gonna put this just, you know. Okay, you know what? No, I'm gonna exit. I'm gonna stop share because I just want to look right into your eyes, you know. Okay. So, yay! You got to see the heaviest Pokemon. You got to see the smallest Pokemon, which is, I think these are the highlights of this workshop. No, I'm kidding. I hope you really understood what the different steps that I took today, and I hope you enjoyed you know, seeing how easy it is to work with Tablecloth, and I also, you know, demonstrated a little bit of that documentation. And what I want you guys to do now is just take a few minutes for yourself, think which things were good and you completely understood. Maybe you have some questions. Think about questions for me. Also, think about the discussions that I suggested earlier. What do you think about the way I cleaned the data? Is it a good idea? Is it a bad idea? You know, maybe we have other options. I'd love to hear your thoughts. And the next thing that you can do now, if you have time, I am going to share these questions that I left. Let me reshare the screen. And I encourage you to go to my GitHub and take that, the workshop core CLJ that I left over there with everything that I wrote today, and try to use that as a reference for answering these questions. And, you know, if you don't succeed, then don't worry about it. I'm gonna post the answers a little later on today. So you'll know, did we, like, oh yeah, we didn't find the heaviest Pokemon, just the biggest one, like, you know, size. I kind of, what do you think? Do you think it's gonna be a Wailord? I don't know. I don't take bets. Yeah. So I think we can do like a short break. Daniel, what do you think? I see we have a few messages in the chat.
Yeah, thank you so much for this, May. That was a joy. And yeah, it would be good to have a short break. And maybe, May, if it is okay, one thing that we could do after the break is maybe to ask Chris, who is here, to say a few things. And yeah, Chris is here. So maybe after the break, we will ask Chris, the author of the TechML dataset and the stack beneath the Tablecloth.
So exciting!
Yes, it is exciting. And then maybe Chris will bring some additional perspective here. And yeah, I think one beautiful thing we saw here is that thinking in rows of the tables is kind of similar to SQL and kind of feels maybe, I think, similar to Clojure thinking. And one other thing that was like an alternative way that Tablecloth offers is thinking in columns. And that is kind of related to a whole stack of high performance computing libraries that we are discussing in other workshops in this month. So if you are interested in this aspect of thinking in columns or in arrays, in a sense, then you may like the workshops about dtype next that will repeat a few times this month. And yeah, maybe we'll ask Chris more about that after the break. And should we take a break now?
Yeah, let's do that. So how many, like, what's a good break for everyone? What's a good break? Like 5 minutes is a good break? What do you say? I think so, because it's enough time for me to go get coffee and run back. So 5 minutes, I'll be back with my coffee. See you guys soon.
See you. Hello, we are back from the break, and we had this presentation by Mey about Tablecloth. And now we'll have some discussion, and Mey has some plan for us to learn more about it. And we thought we could begin this part by Chris Nürnberger, who is the author of Economic Dataset and dtype next, and a few other libraries which are important here. Maybe Chris, would you like to comment about anything related to that?
Yeah, sure. So it is really amazing to have Mey present this work. This sort of thing represents such a large step for the data science ecosystem in Clojure. There are many years where there are very few of us trying to do data science in Clojure, and when we were doing it with tools that weren't as nice as what existed in other ecosystems. And now, thanks to the work of many people, Tablecloth was not written by me. It's a layer on top of some of the things that I've written, along with that combines kind of a lot of knowledge coming from other ecosystems that I don't have experience with, so I could never write it. It's really great to see this much stuff coming together, and I think there's a lot of space for us to take it a lot of directions. The JVM is a very powerful platform. It's shocking that nobody's really tried to do this on it. And it's the oldest platform. This could have been done. This could have done many years ago, and I don't know why it wasn't done, but I'm really glad that it is. I want to highlight one thing. There are also Clojure script bindings for this data frame system. So there are fairly highly optimized ways to send data frames to the client, and there's a much reduced library for working with them on the client, but probably enough so that you can do graphing and you can do quite a bit of computation on the client. So that's one bit that I want to highlight, and that library is called TMD.js. And I think that's also built on Clojure's strength, because Clojure's such a strong client server paradigm in general. Like often when you're writing Clojure code on the server, or on the client, you don't really have to do anything. It just sends it to the client automatically without any effort, and it's just really clear and clean, and it works. And so the data frame system also has that. That's the goal, that you can do most of your data frame processing. You probably should do on the server, but a good bit of it's group by, like you went through, that type of thing is very useful to do on the client a lot of times if it's not too slow. So overall, I'm just overjoyed at these workshops. Thank you so much, Daniel, for being such a consistent person helping the community grow, not just an individual contributor grow. That's big in the long run, and it gives this work a lot of meaning. So these sorts of presentations, this presentation and many others, I find really help, especially right now when I have a young baby and I can't be out there doing a lot of this stuff myself anymore. The time for me to do that again, it'll be a bit before I have the time to put together in-depth presentations about technical aspects of the things I'm working on. So I think that's it for now. I could go on and on because I'm so happy to be here and I'm so happy to see something like this, but I should stop.
Yeah, thank you so much for this. It helps so much to have this perspective. Yeah, Mey, should we continue?
Oh yeah, I was just typing in the Zulip chat the questions, so people can try and do them themselves. Okay, so, and I also owe everyone I also wanted to upload to the Git repo the data sets, so they don't have to open. Yeah, I didn't realize that you need to open a Kaggle account in order to have the data sets, and it was very, was very late at night when I did it, to be honest. So I'm gonna upload it shortly. In the meantime, for those of you who want to go and try and do it, try themselves, I highly encourage you guys to try and do it yourself right now. And if not, we can also start the discussion. Like, that's the first burning question that I have in my mind. Which Pokemon you think you are? No, I'm kidding. But I'm gonna stop with that. I know I'm that this joke is not even funny anymore. I don't know if it was funny to begin with, but okay. No, let's start the discussion about the data. Like, what you guys, I really want to hear your thoughts. What do you think? Do you think it was a good idea the way I handled it? Do you have other suggestions? Speak up or hold your tongue forever. Danielle, you want to be the first volunteer, so you'll help encourage other people to talk? What do you think? Because you were the one who did it with me. So what do you think?
Yeah, I'm wondering. Yeah, I'm wondering. Yeah, so should we read the questions you wrote? Maybe it will be kind of find the heaviest. Oh, should you read? Oh, what would be good?
No, go ahead. I think everyone already enjoyed my voice so much that they can.
Yeah, so I'm reading the questions that Mey wrote. Find the heaviest Pokemon. Which Pokemon has the most wins? Which Pokemon has never won? 0 wins. Which type has the most wins? Check if the Pokemons with the highest attack rate also has the most wins. Right? So these are all things we can check with Tablecloth. It could be fun to try. And yeah, and so Mey, are you suggesting that we try it locally on our machines? And what would be
yes good? Yes, I suggest everyone will try it themselves. I'm going to upload the datasets to the Git right now. But I want to but if somebody doesn't want to do it right now, then you don't have to. And yeah, okay. Maybe there's another thing that you guys can do. If you don't want to go and actually start writing and experimenting, what I can suggest is try to look at those questions and try to go to the documentation and maybe locate at least for the easier ones, the smaller questions that you have over there. Try to think using the documentation, which function would you use based on what we saw today and based on what you can find in the documentation. Maybe try to answer this, in your mind, and then you can decide if you want to run it or not. So yeah, let's take a few minutes for people to do that, and I'll upload the CSV files in the meantime to the Git. I'll do that while you guys think. Okay, so we saw how to start using Tablecloth, and I gave you a little bit of homework, and I encourage everyone to try and experiment with Tablecloth, either with the Pokemon dataset or any other dataset that feels nice and fun. Just a small suggestion: anything that includes, I don't know, Star Wars or alcohol or both sounds funny and fun to me. Go crazy with it. And thank you for participating. If you have any questions, feel free to ping me or Daniel. And again, thank you for listening.